So now we're going to solve a word problem that's going to lead us to a quadratic equation in a minute. But let's look at this first. So a pool measuring 8 meters by 22 meters is surrounded by a path of uniform width. If the area of the pool and the path combined is 1,040 square meters, what is the width of the path? Okay, so I'd like to draw a picture of what we're looking at. It's nice to start with a diagram for these types of problems. So we've got a pool that measures 8 meters, so let's say this dimension here is 8 meters by 22 meters, surrounded by a path, I even have a brown marker here, of uniform width. So same width all the way around. Pretend like that's uniform width. And we're solving for the width of the path. So I'll call the width of the path here x. And so that's all the way around. This is x meters here, x meters down here, x meters down here. It said it surrounds the pool, so it's on all sides. Okay, and the total area for this covered by this entire diagram, so covered by the pool and the path. So the area of this outer, let's say, round rectangle, so I'll write this in brown here, total area is 1,040 square meters. Okay, so area of a rectangle, remember, is length times width. We have a total area which is 1,040 square meters. So total length of the pool and the path. So let's think about that. If you work your way all the way across, and this total area thing is in my way here, so I'm going to get rid of that. So if we work our way all the way across the bottom of this rectangle, I'm going to call this the length. How wide is that, or how long is that? So we've got x meters here, right? And initially, x meters for the path, plus 22 meters for the pool here in the middle, and then some more path on the right side. So plus another x for the width of the path on the right, right? We're going to take 22 and add x to it twice. So 22 plus 2x would be the total length across this. X plus 22 plus x, because we have the path which is with x on either side, and then 22 meters in the middle. So the length right here, oops, use this, is 22 plus 2x, or I like to put the x in front, so I'm going to write it as 2x plus 22. Same thing. Right? If you work your way across the width, so same way, work our way across here, you have x meters at the top for the path, and then you have 8 meters in the middle for the pool, and then you have another x at the bottom for the path again. Right, so you have the 8 meters for the pool plus 2x, because x on the top, x on the bottom, added to get the overall width here. So the width is 2x plus 8. And I'll just reiterate, because this is usually, if I'm teaching this in class, this is what students ask me about, is why are you adding 2x? But so it's x on either side of the 22 meters when you figure out the total length, and then it's x on either side of the 8 meters when you get the total width. And so I want the total length times the total width will give me the total area here. So there's our equation. Getting to the equation is half the battle. And there may be exam problems where that's all I ask you is write an equation in terms of x that could be used to solve this problem. And that would be your answer. Okay, but this is actually a MyMathLab question, and they do ask you to solve for x. So it's nice that this is factored, but if it's not equal to 0, that's not helpful to us at all. So actually, first thing we need to do is multiply this out. This factorization, if it's not equal to 0, it doesn't help us. So 1,040 equals, if you FOIL over here, multiply this out, you have 2x times 2x, so 4x squared. Outside will be 2x times 8, so 16x. Inside will be 22 times 2x, so that's 44x last 22 times 8. Oh, I don't have a calculator handy. 22 times 8. Well, if it's 20 times 8, that would be 160, right? Plus another 16, 136. Here, I better. That's 16. Oh, yeah. Yeah, I didn't add 176. Good thing I double checked. Okay, good. Let's see. So combine like terms. So I'm going to combine like terms over here, and while I'm at it, I'm going to go ahead and subtract 1040 from both sides. So I have 0 equals 4x squared. Combine these guys, so that'll be 60. Right, 60x. This will be what? Hang on. I don't want to do a whole video writing the wrong value. So we have 176 minus 1040, so that's negative 864. Okay. Now, something to notice here, these are actually all divisible by 4. So if you suspect you have a common factor, it's worth checking that out. And with this one, yes, we could actually divide, and get rid of some of these markers in my hand, we could actually divide everything by 4, and it'll divide out evenly. So I'm going to divide both sides of this equation by 4. That gives me 0 divided by 4. 4x squared divided by 4 will give me just x squared. 60 divided by 4 is 15. And then 864 divided by 4 is 216. So minus 216 here. Now, I don't know. I mean, we could sit here and think about, are there two numbers that multiply to give me negative 216 and add up to 15? I don't know about that. To me, that doesn't seem likely. So I'm going to go right to the quadratic formula for this problem. I guess I'll get rid of the statement of the problem here too. Okay, so let me rewrite. We're up to this point. We're trying to solve this quadratic equation. And I'm going to use the quadratic formula. So opposite of b, so that'll be negative 15, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 216. All divided by 2 times a. So this is negative 15 plus or minus, so 15 squared is 225. And then this is going to become plus. This is 225 plus 4 times 216. Oh, wasn't that? That's 864. Because we just divided by 4 and got that. All divided by 2. So when you add 225 to that, we get 1080. Oh, so this was factorable. You get the square root of 1089, which if you take the square root of that, it's 33. So this is negative 15 plus or minus 33, all divided by 2. Once you see that the square root went away, so we did actually have a perfect square under the radical, that tells you that we are going to have rational solutions. We're going to have nice fractions as our solutions. We're not going to have a square root of 3 in our answer. Also, remember that x is the width of the path. If I do negative 15 minus 33, I'm going to have a negative number divided by 2. That's going to give me a negative answer. I know that that can't be the value that I'm looking for. So the value that I'm actually looking for here would be negative 15 plus 33, because that'll give me a positive number divided by 2. And that'll give us, what, positive 15 plus 3, so 18 divided by 2, so 9 meters for that path. Okay, and that was a long road from figuring out overall length and overall width, multiplying this out. If I had stuck with it, maybe we could have factored it. Maybe you can factor it when you solve this on your own in my math lab. We didn't have to use the quadratic formula, it turns out. But you can always, I mean, with numbers like this, if you don't feel like sitting here and thinking about what multiplies to give you 216, or negative 216 actually, then you could switch to the quadratic formula. I mean, it is a matter of just what you're more comfortable doing at that point. And either way is fine, as long as you're coming up with the right answer, and as long as you're solving it, mostly by hand. Here and there where you're crunching the numbers, it's okay to double check with your calculator, but just not using a calculator to solve this equation for you.